Hello students, I hope you all are well and let's start chapter 8 motion, but first recall what we have learned in the last class.
So let's start the chapter 8 motion part 3. But let's start with what we have learned in the last class. Speed and velocity, we have learned the difference between speed and velocity. Speed is a scalar quantity, whereas velocity is a vector quantity. Speed describes by the number only, by the value only, whereas when we are describing velocity, we are supposed to write the number, magnitude, and the direction also. And then we have learned about vector and scalar quantity, but I have told you. Now let's continue and see an example related to average speed. We have learned about average speed in the last class, in the previous slides, where we have find out the average speed with the formula, where what is the formula for average speed? It is total distance covered upon total time taken. Now let's see this in this particular question. What we are supposed to find. A bus travel a distance of 120 km with a speed of 40 km per hour and returns with a speed of 30 km per hour. So calculate the average speed for the entire journey. So here the distance is 120 km. So it's a return trip. So the distance will remain same. Wherever the bus is going, it will coming back to its initial position. So the distance will remain same in both the trips. So distance will remain same as 120 km. Whereas speed for in the first case is 40 km per hour and speed in the second case is 30 km per hour. And according to the formula, we have the distance 120 km, but we need time. So we will find the time with the help of this formula, distance upon speed. So time in case 1 will be 120 upon 40 and time 2 is 120 upon 30. So it's a first trip and it's a second trip, case 1 and case 2. Case 2 when the bus is coming back to its initial position. Now we have speed, now we have time, and we have the value for distance also. Now let's put the value. Average speed is total distance covered, 120. That's 120 at the initial. So the bus is coming back to the initial position. It's a return trip. And the time for the time in the first case is 3 hours and for second case is 4. So 120, add the distance, the value of distance and the values of time. So you'll get 240 upon 7. So your answer will be 34.2 km per hour. So this is the so you're supposed to find the value of average speed when the values of distance and time is given. If the distance and time, if the values of distance and time are not given, then you are supposed to find the value by applying some formulas. Again, there is a question of a displacement. We have seen various examples of finding displacement in the previous slides. So now let's do a question, a numerical based on displacement again. The farmer moves along a boundary of a square field. Here you can see there is a square A, B, C, D, and the farmer is moving around. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? So here you have to relate the time with the rounds completed by the runner, or sorry, the farmer. So here let's see the given values. Total time taken 2 minutes 20 seconds. So let's convert the value of time in 1 unit. The value will be 120 seconds plus 20 seconds. Farmer will cover 3 rounds in 120 seconds. Why? As the farmer is covering 10 meter. As the farmer is covering 1 round in 40 seconds, you can see it's given a farmer moves along a boundary of a square field of side 10 meter in 40 seconds. The farmer will cover a whole round in 40 seconds. So 3 rounds will be covered in 120 seconds. 40 plus 40 plus 40. The farmer will cover 3 rounds in 120 seconds. So the remaining time is 20 seconds. So for the next 20 seconds, farmer will reach to point C. So let's see how does it happen. So let's assume that farmer is running from point A. So the farmer is supposed to take 3 complete round. So this way 1, and then again 2, and the third round. So farmer has completed third round by running around the boundary. And what will happen in the next 20 seconds? See, the farmer will reach to point C. Why? Why farmer has reached to point C? As for 40 seconds, farmer is completing a complete round. So for 20 seconds, half of the time, the farmer will complete a half round of this square. And the half round, if you will start from A, will be completed to at the point C. So we have to find the distance between A and C. Now I have joined a shortest distance between A and C, which is AC. Now how we are going to find out AC? Displacement is the shortest distance between initial and final position. So in triangle ABC, displacement is equal to AC, and you can see ABC is a right angled triangle in which AC is equal to the square of AB plus BC. So the value of AB and BC, as it is a square, all the sides will be equal. So if BC is 10, AB is also 10. So the square of 10 is 100. If you add the values of 100 plus 100 will be 200, and find out the square root, the value will be 14.14 meter. Please remember that in 3 rounds the farmer will complete farmer will complete in 120 seconds. For the next 20 seconds there will be half round, only this much. So you have to find the length of the diagonal of the square. So answer will be 14.14 meters. Now let's continue and see the distance time graph. So here is the distance time graph. We have learned about distance time graph in the previous slides also, where we have seen the uniform motion and non-uniform motion. So the slope of distance time graph represents speed. Now what is slope? Slope is a steepness of this line. How steep is this line? How much is the angle? What is the value of angle between the horizontal line and this line? The line which represents by the graph, is represented in the graph. So the steepness of the line is actually the slope. You can calculate the slope by applying a formula. What is the formula for finding the slope? Slope is equal to y2 minus y1, x2 minus x1. You have learned about coordinates in your previous classes in class 8. What are coordinates? Let's see. I'll take 2 coordinates in this graph. So actually I'm taking x equal to 5, y x1 equal to 5, and y1 also equal to 5. And in the next in what are the next coordinates here? X2 equal to 10 and y2 is also equal to 10. So these are the 2 coordinates. Now we have the value of x2, x1, y1, y2. Put the value in the formula. 10 minus 5, y2 minus y1, y2 minus y1, x2 minus x1, 10 minus 5. So our final fraction will be 5 upon 5, and the speed for this particular graph, for the object which is moving and represented by this graph, motion of the object represented by this graph is 1 kilometer per hour. Please do remember, slope of the distance time graph represents speed. It is a formula for speed. You can find out speed if the values of time and distance is given in the graph. And if the steepness is more, slope of the object will be, slope of the graph will be more. Here is a question. You have to find out which of the 2 car has more slope. So A or B, which has more speed? So speed is represented by slope, and as I have told you, slope is the steepness of this graph. So as it can be easily judged, this steepness of line A is more than B, hence the slope of A is more than B, and hence the speed of A is more than B. The answer is A, as A has more slope. Now the next variable which describe motion is acceleration. What is acceleration? It is change in velocity with respect to time. Just you have learned that velocity is speed. Velocity is a speed and direction. So if an object is changing its velocity with respect to time, then there will be a new variable called acceleration. So its value can be 0, positive and negative. What is the SI unit? Meter per second square. And what is the formula for acceleration? A equal to V minus U upon T. What do you mean by change in velocity? It means that there will be a difference between velocities, two velocities. What are these two velocities? V and U. V is the final velocity of the object and U is the initial velocity of the object. From the word initial and final, you can judge that actually acceleration is a vector quantity. Now we are considering the direction. So acceleration is a vector quantity. So let's do one numerical based on acceleration. Here the velocity of car changes from 54 km per hour to 72 km per hour in 10 seconds. Find the acceleration of the car. Let's first, whenever you are solving a numerical, you are supposed to write the given values first. Then you are supposed to write the formula. Then you are able to solve the numerical very easily. So if you don't know if you don't know the given values, then solving a numerical will be a difficult task. So what are the given values here? T is 10 seconds. Now, why I'm multiplying the value of 54 with 5 upon 18? See, I've told you there is a standard system of measuring units. So time, if the time is in second, in the value of speed, time should also be in seconds. So we have to convert kilometer per hour in meter per second. So how we are going to convert kilometer per hour in meter per second? This you have learned in class 7th. The conversion of kilometer per hour to meter per second is like 1 kilometer is equals to 1000 meter. 1 hour equal to 3600 seconds, and divide the values and you will get a fraction which is 5 upon 18. So for converting kilometer per hour to meter per second, actually we have to multiply the number with the fraction 5 upon 18. And if you multiply, we'll get 15 meter per second for 54 kilometer per hour and 20 meter per second for 72 kilometer per hour. So here are the values. Now we have converted the value in standard in SI units. Let's find the acceleration. Here is the formula again. Acceleration is equal to final velocity minus initial velocity. Now final velocity is 72 km per hour because it is changing to 72 km per hour. So you should know how to find out what are the values of initial and final velocity. Now put the value of initial and final velocity in the formula. Our final velocity is 20, initial is 15. So if you divide these numbers, you can easily see it's 5 upon 10.5 meter per second square. So this is the way you are supposed to solve the numericals of acceleration. Now let's see one more numerical. The car is moving with velocity 20 meter per second, comes to rest in 5 seconds after the application of brake. Find the acceleration of the car. Given values, time is 5 seconds. Initial velocity, the object is moving initially with 20 meter per second. And when you apply the brake, object comes to rest. What do you mean by rest? That the velocity of the object, the speed of the object will become 0. So here our initial velocity is 20 and final will be 0. Time is t, 5 seconds. Now apply the formula. A is equals to v minus u upon t. So here final velocity is 0 and initial velocity is 20. So v minus 20 upon 5, v minus u upon 5, 0 minus 20 upon 5 is minus 20 by 5, which is equal to minus 4 meter per second squared. So here we can see that acceleration actually has a negative value. So if the velocity of the object is decreasing, then you can say that object is actually has a negative acceleration, and negative acceleration is known as retardation. So it's enough for today. In the next class, we learned about velocity time graph, what values we can find out with velocity time graphs, and some numerical based on velocity time graphs. Till then, stay home, stay safe. Thank you.